So we are going to watch a demonstration about a video that shows a demonstration about stability and change that's going to help you better understand populations. So let's watch this and then we're going to talk about it.
This is a system. The system is stable, meaning the level of liquid isn't going up or down. But that doesn't mean that nothing's happening in this system. This top valve allows liquid to be added to the tank, while the bottom valve allows the liquid to be removed from the tank. Right now, the amount of liquid being added is the same as the amount of liquid being removed. This makes the system stable because the level of liquid stays the same over time. If either the amount being added or the amount being removed changes, the system will no longer be stable. It will change. The level of liquid will increase or decrease. If we change the valves so that more is being added than is being removed, the level of liquid will increase. This can be done by either loosening the top valve to let more in or tightening the bottom valve to let less out. Either way, the effect is the same. More is being added than is being removed. Now let's try to get the level of liquid to decrease. To get the level of liquid to decrease, we need to change the valves so that less is being added than is being removed. We can do this by either tightening the top valve to let less in or loosening the bottom valve to let more out. Either way, the effect is the same. Less is being added than is being removed. The liquid will decrease. So a system can be stable even if something is being added and removed from the system, as long as the amount being added equals the amount being removed. But if the amount being added or removed changes, the system will change. If more is added than removed, the amount will increase. If less is added than removed, the amount will decrease.
Everyone's favorite sound. Alright, so in the video it showed liquid being added to a system. So what adds organisms to a population? So in the video you're seeing liquid being added. So how do organisms get added to a population? Well, that is bursts. Let's think about the other side. So in the video, liquid is also being removed. So how do organisms get removed from a population? So in an area, if they're going to just go away, how do they get removed? So that is deaths. So organisms are added to a population by births and they're removed from population by deaths. So let's think about these three questions. So how would you expect, and I'm looking at the first one now, how would you expect the number of births to compare to the number of deaths in a population that was changing? So if the population's changing, how should the births and the deaths compare? So the number of births would be greater or less than the number of deaths. They would not be equal. If they're changing, if you think about the video, if that water is moving, there's either more water going in than there is going out, or there's less water going in than there is going out. So it's going to change its level. So the next question is, how would you expect the number of births to compare to the number of deaths in a population that was stable? So if the population is stable and over a long period of time it doesn't really change, it mostly stays the same, how would the births and the deaths compare? Well, it would have to be equal. Just like in the video, if the water's going in and going out at the same rate, the water level stays the same. So equal number of births, equal number of deaths, we'll have a stable population. So if, this is the last one, if a population is stable, does that mean there's no births and deaths? So how is this shown in the video? We can see the water level staying the same. Was there still water going in? Yeah. Was there still water going out? Yeah. So that relates to population. There's still births, water going in. There's still deaths, water going out. But it's stable because those births and deaths are equal. they're happening basically at the same rate. So that leads us to another key concept, and that is that a system can be stable even as things are being added to and removed from it. If the amount being added and being removed are not equal, then the system will change. So like the video, the water level can stay the same. It can be stable even though there's water going in and water going out. But if the amount of water going in and out are not equal, then the system will change. Then the water level will change. And this is the same thing as in a population. So there's two key concepts here. The last key concept was more about stability and change. It's about thinking about, okay, if the system is stable, then the amount going in and out are roughly equal. If the system is changing, then there's an imbalance. There must be more going in compared to going out, or there must be more going out compared to going in. So, in reference to populations, if the number of births and deaths in a given time are equal, then the population size will be stable. So that is this one. The amount added and removed are equal. If there are more births than deaths in a given time, then the population will increase. More births than deaths. So there's more going in than there is going out. So if there's more going in than going out, then the population will increase. And then lastly, if there are fewer births than deaths, then the size of population will decrease. So if we have less going in than going out, so basically more is going out than going in, then the water level is going to decrease. It's going to go down. So the population will decrease when there are fewer births than deaths.